Hello, students. How are you? Myself, Professor Virendra Kumar, and I welcome you all in this Hira Cosmos video lecture. Today, we'll discuss the chemistry part of your IIT-JEE and NEET syllabus. And in this lecture, we are going to discuss the topic hydrogen. So one of my student is saying that this chapter is not in his book, so it doesn't matter. But this topic is in your syllabus, competitive exam syllabus. So what happens these days that most of the portions are being deleted from the NCRT textbooks for making the uh, study easy for the students. So it may be possible that if some of the portions of the textbook is removed, the students' burden will be reduced. But if for the competitive exam point of view, your burden is not going to be reduced by reducing the chapters from the NCRT textbooks, because in the IITs or NEET UG syllabus, it is there and it must be asked. So why not to study? Why to take the risk? So that's why I thought to cover the second part of the chemistry, class 11, and that is the second chapter, second unit, unit 9, right? So this is the hydrogen, right? So before starting, let's introduce you from our program. So at Hira Cosmos platform, we are providing the online courses as well as the offline courses in very minimum fees. For online courses, each subject, whether it is physics, chemistry, math, or biology, we are providing the whole year study, video lectures, materials, test series in only 999 for one subject for 1 year. And for offline, whoever the students are interested can contact us at the Lucknow office, right? At the given number, right? So let's start the lecture. So, hydrogen is the element with which we are very familiar from our very starting academic career. From class 5th, 6th, we are taught by our teachers that hydrogen is something like a gas, which is the part of our atmosphere. So let's study about this. So this is the modern periodic table. So don't worry if this topic or this chapter is not in your textbook. It doesn't matter because it will cover the chemistry part in the coming section. So it is important to study. I will make this uh, study very useful and easy for you all. So let's start. So and this is uh, dark. So this is the modern modern periodic table. Certainly, this modern periodic table is useful for each and every students who have to study the chemistry. So I think you are able to uh, watch this. So modern periodic tables, they are the groups and they are the periods. So there are seven periods: one, two, three, four, five, six, eight. So total, including hydrogen, there are eight periods, and one, two, three, four, five, six, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, and 18. What? Period. So from starting period 1 to 18. And they are also subdivided into group A and group B. Right. So since and one request for all you students, please the remember the elements n- elements name, symbol, atomic number from 1 to from 1 from 1 to at least 30 directly from 1 to 30, that means from hydrogen to zinc 30, right? So it is easy, and you remember the symbol and the name and the atomic number, and you can also remember the elements for group 1A element like hydrogen, lithium, potassium, rubidium, cesium, francium, like this. Hydrogen, lithium, sodium, potassium, rubidium, cesium, francium, and group 2A, second A, beryllium, magnesium, calcium, strontium, barium, radium. So once you start revising, it will be memorized. So beryllium, these first group are the elements having the valency plus 1, and group 2A are the elements having the valency plus 2. So all these elements, beryllium, magnesium, calcium, strontium, barium, radium, all are having plus 2 valency. And similarly, you can remember this last eighth A, that is the inert gases. They are the noble gases. They don't react normally with any other elements. So helium, neon, argon, krypton, xenon, radon, and ognesium. Ognesium. This is a new element added 294. Ognesium. So helium, neon, argon, krypton, xenon, radon, and Og, ognesium. So these are the noble elements, right? This way you can remember the group A, first A, group second A, last group 8A. These are the very important elements. Now you can remember this third A, that is the boron. These are the very important element also, boron, aluminum. These are the valency third, valency 3 elements. They all are having the valency 3. So if it is asked in your academic exams, write all those elements having the valency 3, all the elements that contains the valency 3. So you can remember what, starting from boron 5, aluminum 13, gallium 31, indium 49, thallium 81, and nihonium uh, 113, and that is also having the 3 valency, honium. So these are the different series. So up to this you can remember, right? So this is the valency 3, valency 4. These are all the valency 4 and semiconductors element, semiconductors. So carbon, silicon, germanium, is- antimony, sternum, plumbum, and flerovium. These black colored elements are newly identified elements, so newly added elements. So you can remember these 4 valence pairs like carbon, silicon, gallium, germanium, sternum, plumbum, and flerovium. These are the fourth valency. So recall with me: carbon, silicon, germanium, stannum, that is also known as tin, plumbum, and flerobium. Like fifth A, that is nitrogen, phosphorus, antimony, uh, arsenic, antimony, bismuth. So nitrogen, phosphorus, arsenic, antimony, bismuth, all these are the elements. And next new one is the mos moscovium. Moscovium. See, so nitrogen, phosphorus, arsenic, antimony, bismuth, and moscovium. So in this way, and this sixth. So see, this is the from here. These all are having the non-metals. So non-metals means they are having the negative valence. They are also called the chalcogens. Oxygen, sulfur, selenium, tellurium, polonium. Last one is the livermorium. So polonium is the radioactive element. So see, these groups are used to come in the exams, at least in the academics. Examiners used to ask, write the group of all the elements who are having the valency minus 2, likewise minus 1, minus 3, right, this way. So next one is the halogen elements: fluorine, chlorine, bromine, iodine, astatine, and last new one is the tennessine. Tennessine. So in this way, you can memorize the elements name group wise, because these are the uh, elements group wise used to ask in the exams. And you must remember, because if you remember the elements name group wise, you can identify them by their physical and chemical properties very easily. That's why it is very helpful to memorize these elements name group wise. And this way also you can remember from starting from the group. These are the group D elements. So from this way, scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc. You remember up to this? Starting from 21 to 30. Scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc. This way you can remember. So let's come to the hydrogen. I discuss these things to make you remember all these elements, name, their atomic number, group wise, period wise. So, right. So up to 30, you can remember, and also you can remember the group wise, and that will be very helpful for you. Now come to the point, what is the hydrogen? So, बच्चों, hydrogen is a very important element that has the wonderful property. It and that's why it is kept at the top of the periodic table. At the top of the periodic table. It is kept at the top of the periodic table. That's why it is here. It is here and here. Wait. And second one is the here. It is also should be here. It is not kept here. See, hydrogen having the, let us discuss some. Yes. So hydrogen atomic number 1, atomic number 1. Atomic number 1 means it has one proton, no neutron, and one electron. So hydrogen is having the one atomic number and one proton and one electron, no neutron. But it has the isotopes. In that you will have the neutron. So, first statement of this NCERT textbook is that, first of all, I would like to tell you that the student who is having the aim to get success in their life should not worry about the syllabus content, that this is not in my book, this is not, and that is not in my book. If it is in the syllabus of the competition, you must be happy to study that, and this will make you enlightened, make you more knowledgeable, bright minded. So be happy, and because I am here to teach you, why to worry? I will discuss each and everything in a very simple and lucid manner, right? So be happy and message me, comment that yes, I like this video, right? So come on. Hydrogen, the most abundant element in the universe, being the lightest, this hydrogen is the most abundant in the universe. Not talking about the globe, the earth. It is talking about the universe. The giant planets like Jupiter and Jupiter, they are having the huge amount of the hydrogen. But on the earth, it is in the small quantity. There are reasons because it is the lighter, lightest in the weight, and it has the uh, capacity to be escaped. So that's why hydrogen, the most abundant element in the universe mass wise, and the third most abundant on the surface of the globe. The most number one in the universe, means whole solar system, up to what we have the knowledge about, is the number one, right? And third most abundant on the surface of the globe, that is the earth, is being visualized as the major future source of energy. Why? If it is asked in your competition, why the hydrogen is to be thought as a future source of energy, because this is clean fuel. When it is burnt, only water vapor used to release. No byproducts, no greenhouse gases, no harmful uh, gases. That's why it is it is thinking that we can utilize the hydrogen as a clean source of energy, and it is freely available in our environment. That's why we can harvest it. That's why it is known as the major future source of energy, right? So hydrogen having the atomic number one, and it shows the both property, plus one and minus one, because if it is having the one atomic number, that means so see, hydrogen, one atomic number, so if we write the electronic configuration, it shows the 1s1. So if it releases one electron from its cell, it will become the hydride. No, hydrogen, positive proton like feature, it will have proton. And if it accepts the one electron, it becomes the hydride. So to make the octet, make the cells completely filled, it has the two way. First, to release its own electron to become the proton, and another is to accept one electron to become the hydride ion, right? So because of this property, hydrogen is kept in the first A group as well as the seventh A group, in the group of fluorine, chlorine, bromine, iodine, astatine. that are having the negative one valency. You know, fluorine atomic number 9, chlorine, bromine, iodine, astatine, bromine, iodine. They all are having the, oh sorry, what I am writing. Chlorine 17, bromine 31, right? And 35 and 53, 35 and 53. And if we write their electronic configuration, so they will be in the 7s, right? I see. Oops. क्या है भाई? They will have the negative -1 valency. All these elements are having the negative -1 valency, and hydrogen is also capable of having the negative one valency. That's why it is kept at the top of the periodic table at the both places. So there is a good debate over this, and this makes the hydrogen unique element. Hydrogen has the simplest atomic structure among all the elements around us in the nature. In atomic form, it consists of only one proton and one electron. So one atomic number means one. If you draw, if you draw the, so if you draw the orbital cell, so there will be nucleus and there will be one cell K. So cell number is designated as K, L, M, N. So it is having only one cell, that is K, and one electron is there in the cell and one proton is in the nucleus. So it is only having the one proton and one electron, right? That is the property. However, in elemental form, it exists as a diatomic molecule and is called the dihydrogen. So it exists in the, like chlorine, it exists in the dihydrogen form. Means it exists as a molecule, right? It exists as a molecule. H2 dihydrogen. We call it dihydrogen. We call it dihydrogen. Okay. Do you know that global concern related to energy can be overcome to a great extent by the use of the hydrogen as a source of energy? These days, we are using the fossil fuels as a source of energy, like petroleum, diesel, petrol, kerosene, right? All, and biofuels like coal, uh, woods, and for that we are cutting the jungles, forests. So, if we use hydrogen, we can save our environment by not producing the greenhouse gases, right? And because hydrogen is the clean energy, yeah, hydrogen can be utilized as a clean energy source. So it is our hope that if we use the hydrogen, it may be helpful for our environment as well as it can fulfill our fuel needs. So position of hydrogen in the periodic table. So some part of it I have already talked to you. So let's move again, move further. So hydrogen has been a subject of discussion. Hydrogen has electronic configuration 1s1. On one hand, its electronic configuration is similar to. So I have all talked the alkali metals. So group one. See, this group 1A is the alkali metals, and this group 7A is the halide. So, so this is the electronic configuration for the halogens. So, halogens, that is collective name for the fluorine, chlorine, bromine, iodine, astatine, uh, right? So, halogens, that is the NS2 NP5. So, NP5. So, this is the SPDFG H orbitals. These are all called orbitals. Orbitals. So the last electron is occupying the p orbitals, and in p orbitals, see, there are maximum 6 electrons, right? So if we fill this, so last electron is left single, and that will try to be paired for making the octet complete. So that's why it will try to accept the single electron, and that's why the valence is -1, right? So halogens all are having the these all elements. So all are having the negative one valency, and the hydrogen matches this property. That's why the hydrogen is here. And again, alkali metals are alkali metals. What? Hydrogen, starting from hydrogen, lithium, sodium, potassium, rubidium, cesium, francium, all are having the NS1 type of electronic configuration. So these are the first and second group is the S block, right? And these are the P block. These are the P block. So, and this N, what does it show? It shows the period number in which, so see, 1s1 means first period, and if you take the lithium is having the three atomic number. So, electronic configuration is 1s2, 2s1. So, right. So, again, 1s2, 2s1. So, second period, right? So, 2 means period number 2. Right, period number sorry this cell number 2, right, cell number 2, and this is the vertical period group, sorry, this is the group, first group we call vertical column is called the group, and the horizontal row is called the period. So this is the second period, and it is in the first group. So the last last electron uh, here generally shows the group number. So one, that is the first group. If it was two, that will be the second group. But this number shows the cell number as well as the period number. So this way you can also uh, write for the beryllium, that will show the beryllium 4. So that then it will be 2s2. That means group 2 and period stem 2. Right. I hope that you understood. So this is the thing about the matching properties of hydrogen with the alkali metals as well as the halogens, that is the non-metal. Right. Now further, hydrogen has resemblance to alkali metals as well as the halogens. Okay. Right. Again, however, unlike alkali metals, it has a very high ionization enthalpy, and does not possess metallic characteristic under normal conditions. So, see, hydrogen enthalpy is very much in thousands more than the alkali metals. What is enthalpy? Enthalpy is the total energy. Enthalpy H is the E plus PV, internal energy plus work done PV, pressure into volume. So total enthalpy, ionization enthalpy, that means total energy, very high ionization energy, means it requires enough more energy to be ionized in comparison to the alkali metals. So what is the consequence of that? And but see, consequence I will tell you. And it is less than the see, this is the enthalpy. And less than, here it is written less than the I will tell, like halogens. So because of that property, it is kept at the top. In terms of ionization enthalpy, hydrogen resembles more with halogens, and delta H of lithium is 520 kilojoule per mole, and fluorine is 1680 kilometer 80 kilojoule. So hydrogen enthalpy is 1312 kilojoule. So if we write these all values at one place, so enthalpy for hydrogen, that is the 1312 kilojoule per mole, and for enthalpy for alkali metals, it is 520 kilojoule per mole, and for the halogens enthalpy is 1680 kilojoule per mole. So you can see that in terms of enthalpy, ionization enthalpy, hydrogen is much closer to the halogen, and it is having the more than the alkali metals, right? Again, it forms a diatomic molecule, dihydrogen. We have talked about it, and combines with the elements to form hydride. So metal hydrides, it used to form the hydrides with the uh, single element, like how HCl, NH2, right? And other example is that what, CaH2, calcium hydride, all these are, this type of compound it is to form. So combines with elements to form the hydrides and a large number of covalent compounds. So it forms the hydrides as well as the covalent compounds, and that is the hydrides, or that is the points of our study further, hydrides and covalent compounds. Another point of starting this chapter is also that first chapter, redox, is already been started by the Mahima ma'am, and that's why I started the second unit, and that is the unit number 9, because we can't jump directly to the higher number of chapter. There will be the knowledge gap, and it will make you difficult to understand the things, right? But in terms of reactivity, hydrogen is very low as compared to halogens. So if we are comparing the reaction speed, that is the reactivity, halogens are more reactive than the hydrogen, but alkalis are less reactive than the hydrogen, right? But in terms of enthalpy, hydrogen ionization enthalpy is more than the alkalis and very close to the halogens. In spite of the fact that hydrogen to a certain extent resembles both the alkali as well as the halogen, it differs from them as well. Now the pertinent question arises as a where should it be placed in the periodic table? So loss of the electron from hydrogen atom results in the nucleus H plus. See, I told you that 1s1 if hydrogen 1s1 if loses its one electron, it becomes the H plus ion. H plus ion, and if H plus means there is no electron, only the nucleus is left. One proton is left, and its size will be the 1 point size of the nucleus, 1.5 into 10 to the power minus 3 picometer, right? Picometer and size. This is extremely small as compared to the normal atomic and ionic sizes of the. So since the hydrogen is having the very initial element series, sorry, since hydrogen is coming at the top of the all atomic numbers, it starts. So size of the hydrogen must be smallest among all the elements because size of the elements decided by the atomic size, and there if there is no electrons, only the nucleus is left, so size definitely will be and nucleus with the only one proton, so size of the nucleus will be itself very small. If there are more nucleus, the size of the nucleus may be more to occupying the all those nucleons, right? So it is very extremely small compared to the normal atomic ionic sizes. That is normal range is, so make it point. Normal range of atomic nucleus, normal range. It here is the point. The normal range of atomic nucleus is 50 to 200 picometer. Pico means 10 to the power minus 12. Pico means 10 to the power minus 12. So this is the normal range. And our hydrogen is very small, 1.5 into 10 to the power minus 3. So it makes very small in comparison to this number. So as a consequence, H plus does not exist freely. So what happens if this is a very small number, size of the nucleus is very small. So that's why hydrogen plus H plus does not exist freely. Freely, it is available in the combined form. So it is associated with the other atoms. Thus, it is unique in behavior and therefore best placed separately in the periodic table. Right. So now the dihydrogen. So it is not available freely. That means it is in the molecule form. Dihydrogen. Dihydrogen. That is H2. H2. Okay. Let me check whether we are visible or not. Okay. So dihydrogen. Dihydrogen is the most abundant element in the universe and is the principal element in the solar atmosphere. So dihydrogen is the most abundant element in the universe. So as the hydrogen is the most abundant element, most abundant, H2 is also most abundant in the universe. 70% of the total mass of the universe is the hydrogen. You can imagine. If 100 is the number of total mass of the whole universe, 70 out of 100, 70 is the hydrogen. You can imagine the abundance of this hydrogen, dihydrogen, and hydrogen. Right? So it is abundantly available in the universe. Why not to talk about the hydrogen? And hydrogen is important in the hydrocarbons as well as in the organic compounds. That's why I started from this chapter, dear students. And in the whole solar system, if you talk, the giant planets like Jupiter and Saturn consist mostly of the hydrogen. However, due to its light nature, it is much less abundant on the Earth's surface. Atmosphere. So on the Earth's atmosphere, only zero of whole gases, atmospheric gases, atmospheric gases on Earth, only 0.15%. How much? 0.15% is the dihydrogen. 21% around is the what? Oxygen. 78% is the what? Nitrogen. So how much left? These two makes the 99%. And this is the uniqueness of our atmosphere. What is the beauty in our atmosphere? Nitrogen plus oxygen makes the 99% of our atmospheric gases. Only 1% makes the other gases. And out of that is the hydrogen 0.15%. Carbon dioxide is the 0.003%. So out of 1%, all other gases are there in the atmosphere. So what makes beauty of this atmosphere is the 78% and 21%. And oxygen is useful for breathing of the human lives, animal lives, and nitrogen helps in burning. So together these gases plays a vital role in sustaining the lives on the earth. That is the beauty of our atmosphere. If nitrogen is not there, it will be very difficult to extinguish the fire, I think. See, uh, so let's do some research. I have a point in my mind. So research for the use of nitrogen. Nitrogen for life. Go. See, nitrogen is the most abundant element in the air we breathe, 78%. Without nitrogen, there would be no life on the earth. Find it. Without nitrogen, there would be no life on the earth, no chlorophyll, no hemoglobin, no plants or animals. You might have no. While carbon gives the basic skeleton of the organic matter, nitrogen is the fundamental to life's functioning and diversity. Right now, you can imagine the and nitrogen for burning. Nitrogen does not help in burning, so that means it is helpful for extinguishing the fire. right? Right now, help in extinguishing the nitrogen works by reducing the oxygen level in the space to where the fire will extinguish automatically. So if you remove the nitrogen, what will happen? It will be very difficult to extinguish the fire. Now come to the point, right? So we do the research and they get familiar how the nitrogen is important and how the oxygen is important. Most of you might have known that only the oxygen is important for life. Nitrogen as well is important for our life sustainability on the earth. No nitrogen, no life. Diversity of life will be not available. So now come to the isotopes of the hydrogen. So isotopes of the hydrogen, there are three types of isotopes. There are three types of isotopes. One, one H1, one H2, one H3. Name is protinium, protinium. Second name is the deuterium, deuterium. And third one is the tritium, tritium. स्पेलिंग ध्यान से लिखना भाई. So these are the isotopes of hydrogen. So now mind it. Protinium, deuterium, and tritium. Atomic number is same for both. That's why it is the isotopes. That means those elements which have the same atomic number but the different number of neutrons, that means atomic mass, is called the isotope. So isotopes is available for only the single type of element because of their mass, different mass number or different number of neutrons in the nucleus. So here, if you write number of proton and number of neutrons, one proton, zero neutron. In the nucleus की बात कर रहा हूँ, nucleus. And in deuterium, one proton, one neutron. And in tritium, one proton and two neutron. So which one is heavier? Tritium is the massive than the other two, and deuterium is the massive than the protium. And this tritium is the is having the unique property of radioactivity. Radioactivity. Tritium is the having the property of radioactivity. लिखा भी होगा, नहीं लिखा तो कोई बात नहीं. ट्राइटियम जो है रेडियोएक्टिविटी प्रॉपर्टी होता है. Right? And I'm not going to discuss about the protium. That is the hydrogen one. You know everything about the hydrogen. This single hydrogen protium, single proton and the zero neutron protium. Now the different important things about the deuterium and the tritium is that deuterium is also known as the heavy hydrogen, and we denote this as the D, capital D, and this as the capital T, tritium. So heavy hydrogen, and this makes the heavy water just like normal water. Just like normal hydrogen, protium makes the normal water. We use so heavy water, heavy hydrogen makes the heavy water, D2O. And this protinium makes the normal water, H2O. And heavy hydrogen makes the heavy water. So what is the heaviness? Useful or not? Heavy water, heavy water. This heavy water is used in the nu- nuclear reactor. Heavy water is used in the nuclear reactor, and it its heaviness is utilized as the moderator or barrier for stopping the neutrons further bombardment. Because in the nuclear reactor, so neutrons are bombarding and knocking out the another uh, nucleons. So we use heavy water to reduce the speed of the neutrons. So there it is utilized heavy water, right? So see, as per the NCERT textbook, these isotopes differ from one another respect of the presence of neutrons. We discussed uh, ordinary hydrogen, that is the protium, has no neutrons, deuterium has only one neutron, and the tritium has two neutrons in the nucleus. And Harold C. Urey, note it down. That is the important point for your competition. Harold C. Urey, Harold C. Urey was the scientist who got Nobel Prize, got Nobel Prize for separating the hydrogen isotope of mass number 2 by physical method. So got Nobel Prize for separating hydrogen isotopes by क्या लिखा है by मास नंबर 2. मास नंबर 2 मतलब क्या हुआ भाई? मास नंबर 1 is 2, मास नंबर 2 that is deuterium. सो ये नाम जो है ऑब्जेक्टिव क्वेश्चन में आ सकता है कि द नेम ऑफ द साइंटिस्ट हु गॉट द नोबेल प्राइज फॉर सेपरेटिंग द हाइड्रोजन एटम फ्रॉम द आइसोटोप्स बाय मास नंबर बाय यूजिंग द फिजिकल मेथड से उन्होंने अलग किया था. सो दैट इज द इम्पोर्टेंट पॉइंट, राइट. नेक्स्ट, प्रीडोमिनेंट फॉर्म इज द प्रोटियम, दैट इज हाइड्रोजन. Mostly abundant this is a hydrogen. Terrestrial hydrogen contains 0.015% of the deuterium, mostly in the form of heavy D. Right. So, what does it mean? Protium is the universally abundant. That is okay. Terrestrial hydrogen means on the Earth, hydrogen contains 0.0156% of the deuterium mostly abundant. So hydrogen deuterium mostly abundant. So this is the hydrogen. Terrestrial hydrogen is this much of deuterium available in the form of HD. ठीक है. अब एच डी है, इसमें जो है एच डी हाइड्रोजन और ड्यूटेरियम दोनों है, प्रोटियम एंड ड्यूटेरियम. इसमें जो है केवल 0.0156% क्या है हमारा, क्या है, टेरेस्ट्रियल हाइड्रोजन है. रेस्ट इज द ड्यूटेरियम. ठीक है. द ट्राइटियम कंसंट्रेशन इज अबाउट 1 atom per 10 to the power 18 एटम्स ऑफ प्रोटियम. सो आप देखिए हमारा टी कितना है, 1 out of 10 to the power 18 एटम. यदि हम प्रोटियम का 10 to the power 18 एटम्स लेंगे तो उसमें से एक निकलेगा क्या, ट्राइटियम. Of these isotopes, only tritium is radioactive, and I have already discussed, and it's emit low energy beta particles. That is a Beta particle having the half life 12.33 years. So tritium releases beta particle, that is the negative charges, and T half. Here it is written T half is small t because of this T. So T half is equal to 12.33 years. What does it mean? Students, have you studied about the radioactivity, becquerel rays are all? There is a concept that is a half life, the time in which the radioactive elements becomes half of their mass. जितना भी संख्या है उनकी है उसकी आधी हो जाती है उतने टाइम में, उसको ही हाफ लाइफ बोलते हैं। इसका मतलब रेडियोएक्टिव एलिमेंट ट्राइटियम का जो हाफ लाइफ है 12.33 ईयर्स, मींस इफ इट इज 1 ग्राम ट्राइटियम टुडे, so it will take 12.33 years to be half of that, right? So after 12.33 years, only zero point 0.5 gram tritium will be remained because of the radioactive nature. It will be emitting the beta particles continuously and be reduced by the mass. So one beta, this is the beta particle, right? So next, atomic and physical properties of hydrogen. Let's see, let's view over this table 9.1, atomic and physical property. This is the hydrogen, this is the deuterium, and this is the tritium. First row is relative abundance. So you mind it, 99.99, 98, 99.985 means 99.99% is the हाइड्रोजन 1H1। पूरे यूनिवर्स में इतना अब क्या बचा पूरे हाइड्रोजन का? 99.99 तो क्या है? प्रोटियम है। ड्यूट्रियम 0.156 एंड ट्राइटियम 10⁻⁵। रिलेटिव एटॉमिक मास, सो एटॉमिक मास 1 है, इसका 2 है, इसका 3 है, इसीलिए तो हमारा 1H1 1H2 एंड 1H3 हुआ था। दैट इज बिकॉज ऑफ दिस only, right? So this is the atomic mass. So in round figure we have written 1 2 3 1.008, 2.014 and 3.016 melting point and boiling point for in terms of Kelvin. So at the 13.96 hydrogen will be melted. That means what? You know, if you want to change the 10 degrees Celsius into Kelvin, then you have to add the 273 plus 10 to get the Kelvin number, right? So imagine if it is 13.96, even 14 Kelvin, so what will be the temperature in terms of the degree Celsius? It will be very, very less. That means it is not possible to have the to have the hydrogen in terms of the liquid. It is always in gas, boiled to the gas vapor. Because the boiling point, melting point, boiling point is so less, right now. If it is total value is 13, 14, 20, so degree centigrade is going to be in the minus. So that's why it gets melted, gets boiled at a very, very negative temperature, right? Density 0.01, 0.09, 0.18, 0.27. Enthalpy of fusion, enthalpy of vaporization, enthalpy of bond dissociation, these are all values. So ionization enthalpy we talked about 1312 kilojoule per Kelvin per mole, right? So these are the parameters, physical properties of hydrogen. Let's move further. Now the point is, since the isotopes have the same electronic configuration, they have almost the same physical chemical properties. Same electronic configuration means why? When you write the electronic configuration, that is based on the atomic number only. atomic number only. Electronic configuration is based on, and it may be asked in the exam, is based on atomic number, and our periodic table is made up, and our periodic table is based on the electronic configuration. Based on the electronic configuration. Electronic configuration. So ultimately, what our periodic table is based on the atomic number. Got it? So since for the all the three isotopes, atomic number is same, so chemical properties of the all the isotopes will be similar. The only difference is in their rate of reactions, mainly due to their different enthalpy of bond dissociation. You noted, na? You noted or not? Bond dissociation, enthalpy of bond dissociation is 435.88 for the hydrogen and 443 for the deuterium. So little bit more than the hydrogen for the deuterium. For deuterium it is little bit more in comparison to the hydrogen in case of the enthalpy of bond dissociation. Right, and it is at the 290.8 Kelvin. At means 298 means Kelvin का मतलब कितना हुआ? This is in Kelvin. So we'll get the degree centigrade by reduce and subtracting 273. So almost at room temperature. At room temperature की बात कर रहा है कि ये वैल्यू जो है रूम टेम्परेचर पे जो कितनी है, हाइड्रोजन केस में 435.88 किलो जूल पर मोल एंड 443.35. However, in physical property, these isotopes differ considerably due to their large mass difference. So physical properties में उनका mass जो है रोल प्ले करेगा. So on the basis of their mass, they differ. Isotopic isotope different isotopes of hydrogen will have different physical property due to their mass differences. Right. So in the next section, we will study about how can we can prepare the dihydrogen in the laboratory as well as in the industry. That is a commercial production, and after that we will discuss the properties of dihydrogen, physical properties, chemical properties, and reactions. So I hope that you like this video, and since we are teaching students on the very nominal charges, only we are taking the registration fees 999 for one subject for 1 year. So we are inviting all those students from all over India to get this opportunity and learn from the Hira Cosmos, and we are providing the best learning way, as much as possible, as much as we have the caliber to deliver you. So, but your feedback is utmost for us. You please provide your feedback. How did you like these videos we are providing to you, so that this will make us more digestible for you, what we provide. So thank you, friends. Thank you, my dear students, for watching this lecture. Meet you soon in the coming video lecture. Thank you so much.